In our previous lessons, we learned that if lines are parallel, then corresponding angles are congruent. If lines are parallel, alternate interior angles are congruent. If lines are parallel, alternate exterior angles are congruent. And if lines are parallel, then same side interior angles are congruent. Or excuse me, not congruent, they are supplementary. So what we're going to do today is we're going to talk about the converse of that. So remember that when we talked about converse way back in Unit 2, our original conditional was if P, then Q. And our converse was switching that around, switching our hypothesis and our conclusion, if Q, then P. And so we're going to use that today to be able to find out something new about our parallel lines. So before, what I knew was if the lines were parallel, that's the part that I knew. And because I knew the lines were parallel, then I could talk about the angles. Well, today what we're going to do is we're going to do something similar, only what we're going to start with is we're going to start knowing about the angles. And since we know about the angles, then we can make decisions about the lines. And the decision that we can make is, are they parallel or not? So there are four ways to show that lines are parallel. Okay, and it's using the converses of those theorems that we used in our last lesson. If corresponding angles are congruent, then that must mean that our lines are parallel. Originally, the conditional said if lines are parallel, then corresponding angles are congruent. We started knowing that the lines were parallel, therefore we could talk about the angles. Today, we're going to start knowing about the angles, and then we're going to talk about the lines being parallel. If alternate interior, so remember corresponding angles, they formed that F. Alternate interior angles, and so if we have angles that form a Z, and if they are congruent, then that means that our lines are parallel. If I have alternate exterior angles, and I happen to know that those alternate exterior angles are congruent, then that means that my lines must be parallel. And then lastly, if same side interior angles, which would be these two, for example, if they are supplementary, or if they equal 180, then the lines are parallel. So we're just using the converses of what we've already learned. Now, one thing that is extremely important, highlight this, circle it, star it, make this stand out. Vertical angles and linear pairs do not say anything about parallel lines. Now, vertical angles are congruent, linear pairs are supplementary, but they do not prove that lines are parallel, and the reason is this. Remember that we talked about that corresponding angles for those two corresponding angles have to be on their own vertex. Alternate interior angles, alternate exterior angles, corresponding or same side interior angles, they all have their own vertex. Vertical angles, remember, they share a vertex, and linear pairs share a vertex. They don't even create, right? If all of our parallel lines, we had two lines and a transversal, two lines and a transversal. Well, if you look at these lines here and these lines here with vertical and linear pair, there's only two sets of lines. We don't have that transversal, and remember that a transversal is a line that crosses two or more other lines. So vertical angles and linear pairs never ever prove that lines are parallel. We may need them to solve parallel line problems, but they don't prove that lines are parallel. So let's look at some problems with this. So if lines are parallel, which ones and why? So if I know that angle 1 is congruent to angle 3, so I know that those two angles are congruent, then which two lines can I say are parallel? Here's what you're looking for. You're looking for two lines that run in the same direction with one line that cuts across them. So if you see, notice that I've got C and D are both sides of those angles, and that A is that transversal. And so what I can say because of this is because those angles are congruent, then I can say that C is parallel to D. Okay, I can say C is parallel to D because angle 1 is congruent to 3 and they are corresponding angles. Okay, so let's look at 7 and 12. So here's 7, Here, I just trace the sides of 7, and I trace the sides of 12. So notice if I extend those lines, I have my 2 lines that go in the same direction, and my transversal is D. So if 7 is congruent to 12, they are alternate interior angles. The theorem says if alternate interior angles are congruent, which I just said they were, then A must be parallel to B because they are alternate interior angles. They're congruent. So let's look at 10 and 11. So I have angle 10 and I have angle 11, and I notice that they are same side interior angles. And this says that if same side interior angles are supplementary, which they are, then those lines must be parallel. So which lines? Well, look for the 2 that are going the same direction. So C is parallel to D because they are same side interior angles and they are supplementary. So the same side equals 180. Now remember, they could be same side and not be supplementary, but that just means that the lines aren't parallel. They can still have that location of being on the same side and not be supplementary. So 13 and 10, here's angle 10 and here's angle 13. Okay, so I look at those and those are not corresponding. They're not alternate interior, they're not alternate exterior, and they're not same side interior. Notice that those 2 angles share that one vertex. Well, those are vertical angles, and vertical angles never prove that lines are parallel. So I cannot say, based on this given information, that any lines are parallel because vertical angles do not prove that lines are parallel. That's important. Okay, and then our last one is 4 and 15. If I look at 4, here's angle 4 and here's angle 15. Angle 4 and angle 15, notice they're on this same transversal. I just travel 1 line to get there. 4 is also made up of A. 15 is also made up of B. So I can say that A is parallel to B because if alternate exterior angles are congruent, then those lines have to be parallel. So you're going back to like the very first lesson where we learned how to isolate the 2 lines and the 1 transversal. That's what we're doing, is we're looking for the 2 lines that go in the same direction because those are going to be the ones that are parallel. So based on the information, let's determine if any of the lines are parallel. So I have angle 9 and angle 7. If you want to try these on your own, just hit pause, try it on your own. So I have 9 is congruent to 7. I'm telling you 9 is congruent to 7. So if 9 is congruent to 7, notice that I can extend these lines, and I've got my 2 lines that travel in one direction, and then I have my transversal that cuts across them. So I need to look for the ones that are parallel. So I look, AC, remember this top line can be named AB, BC, AC. So I'm going to name it AC because that's the one that's up here. AD is not that line and AE is not that line. So it has to be A because if alternate interior angles are congruent, then the lines are parallel. So 2 and 5, here's 2 and here's 5. If I trace the sides and extend the lines out to make it a little bit easier to see, I can see that I have 2 lines and a transversal. My 2 lines are AD and BE, so that means that they are parallel because these are corresponding angles. And if corresponding angles are congruent, then lines are parallel. Nine and 8 are supplementary. So here's 9 and here's 8. I'm going to extend my lines out to make them a little bit longer, even though I'm talking about these angles. And what I know is that those equal 180. Well, I notice that those are same side interior angles. And same side interior angles are supplementary. And if that's true, then the lines are parallel. So that means that AC is parallel to DF. And the last one, 4 is congruent to 10. So here's the sides of angle 4. And here's the sides of angle 10. If I extend those lines to make them just a little bit easier to see, I can see my two lines that go the same direction, AE and BF, and then cut the transversal BE. So AE is parallel to BF because if alternate interior angles are congruent, then lines are parallel. Okay? So let's look at this one. Given that A is parallel to B, I think it's easier if you'll highlight them. I am telling you that A is parallel to B. Now, I don't know anything about CD. I know they look parallel, but that doesn't mean that they are unless I give you information that says which statement is not a valid conclusion. So let's look. So I am saying that 5 is congruent to 10. So if I tell you that 5 is congruent to 10, does that mean that A is parallel to B? Well, yes, if I trace 5 and I trace 10, notice that the two lines that go the same direction are A and B, and C is the transversal. So that is true. Is 3 congruent to 11? Does that mean, so here's 3 and here's 11. Again, notice if I extend those lines out, A and B are the ones that travel in the same direction, and D is the transversal. That's how I went from one vertex to the other. I traveled along D, so that's the transversal. Then I look at 13 and 15. So here's 13 and here's 15. So if I travel from 13 to 15, I travel along B and I cross C and D. So that one has to be the one that's wrong because that one would tell me that C is parallel to D, not that A is parallel to B that we know. Okay. Same type of question, given that C is parallel to D. So let's start with this. We know this. So based on that, which statement is not a valid conclusion? So I look and I check 6 and 3. So first, if 6 is congruent to 3, does that tell me that C is parallel to D? Yes, because those are alternate interior angles. Notice that I travel along A to get from one vertex to the other, so my transversal is A, which leaves me with C and D. That's true. So then I have that 1 and 4 are supplementary. Well, 1 and 4 are not any angles that I know of. I'm not sure if that's the answer or not, so I'm going to put that one on hold for just a second because that's different than anything we've done so far. So I want to come back to that one. Then 14 is congruent to 16. So I've got 14 here and 16 here. If those two angles are congruent, does that prove to me that C is parallel to D? Well, notice I travel from this vertex along B to that vertex. So B is my transversal. That means C is parallel to D. So that one checks out. Then I have 7 is congruent to 12. If 7 is congruent to 12, notice that I travel from 7 to 12 along D, which means that A and B are my parallel lines. So I wasn't sure about B, but I know that D is wrong because D means that A is parallel to B. So then that must mean that B is right. So sometimes if you don't know, go look at the other ones and see if you can come back to it. So the last question says to find the value of X that make AB parallel to CD and that make AC parallel to BD. So I want to look at this, and so I want to find the values of X. Well, here's what has to happen. In order for those two lines to be parallel, then these two angles have to be same side supplementary. They are on the same side of the transversal. This angle right here and this angle right here, these two, they're on the same side of AC and they're both interior. They need to be supplementary in order for those lines to be parallel. So we would set it up. This angle, x plus 8, plus this angle, 2x plus 22, has to equal 180 for those lines to be parallel. So on my left-hand side of the equation, I have some like terms. So I have x and 2x, that's 3x. And I put my positive 8 and my positive 22 together, so it's plus 30 equals 180. I'm trying to get my x values by themselves, so I'm going to leave this guy sitting there because it's the only one that has x's. It's a positive 30, so I'm going to subtract 30. Those cancel out. That leaves me with 3x is equal to 180 minus 30, which is 150. Then that's 3 times x, so I'm going to do the inverse, which is divide. So x is equal to 50. So I know that x is equal to 50. Well, if x is equal to 50, now I need y. So I'm going to come over here and I'm going to look. Well, here's angle y. Well, angle y, if these two lines are parallel, if AC is parallel to BD, then that means that these are same side interior angles also. So if x is 50, then this angle is 2 times 50 plus 22. So this angle is 122. That's this angle right here. That means that this angle has to be 180 minus 122, which is 58. So y then is 58. So we've used the converse of the theorems that we used the other day. If corresponding angles, alternate interior angles, or alternate exterior angles are congruent, then that tells me that the lines are parallel. If same side interior angles are supplementary, then that tells me that the lines are parallel. Now, vertical and linear pair never prove that lines are parallel because you cannot see 3 lines. That's what you're looking for, is you're looking for 3